Hello friends, very good morning. Before I start my today's video, I would like to thank you very much with my folded hands because you have supported me to make this 500th video on the subject engineering drawing and machine design. It was all possible because of your cooperation, your subscription to my channel, and your viewership enabled me to reach this level of making 500th video. Friends, I thank you wholeheartedly for your contribution to make my channel one of the leading channel on this subject. Friends, let's see what is the question we have for today's video. The question for today's video reads like this. A cone diameter of is 50 mm and axis 70 mm long, resting on its base on HP, is cut by two section planes. So before we go to the section plane and all, let us see how to place the object. So generally for all these problems on solids, the initial position is that we are going to place the object on HP such that its base is completely in contact with the horizontal plane. So we obtain the top and front views. Friends, in any problem on these cones, we are going to have it placed on HP such that the base is in contact with HP and it is seen as a circle in the top view, whereas the front view is going to be a triangle. So in this problem, I am going to draw the top view of the cone, a circle of diameter 50 millimeter, and height of that is given to be 70 millimeter. So I am going to mark a line here and say the height as 70 mm. So this is the height of the solid. And further he says, before that friends, let us mark this. So this can be marked as A, B, C, D, E, F, G. There's no place to mark the remaining. So this is going to be A dash, this is E dash, C dash, G dash. The axis is perpendicular to HP. And friends, it is being cut by two section planes and both the section planes are normal to VP. So cut by two section planes which are parallel to each other and inclined 30 degrees to HP. Very obviously they are going to be perpendicular to VP, and these two are parallel to each other and they have given the condition that they are inclined at 30 degrees to HP. Suppose this is inclined at an angle of 30 degrees to HP. The other one is also inclined at 30 degrees to HP because these two section planes represented by S1, S1 and S2, S2, they are parallel to each other. So very obviously, they will have the same inclination with the horizontal plane. And further it is said that one of the section plane is inclined at 30 degrees to HP and passing through one of the extreme ends of the bottom face. Bottom face is A dash E dash. It can be like this or it could be like this also. But I have shown the section planes inclined to the right side and making an angle of 30 degrees. And the distance between these two is given to be, and distance between them is 25 millimeter. So friends, this gap wherein we are writing the distance of these two, it is given to be 25 millimeter. So 25 mm is the perpendicular distance between section planes S1, S1 and S2, S2. Friends, we have marked the top view. We have transferred the points here. This is O dash, this is O, and we have got two section planes. After placing the solid on HP, marking the section planes, next we have to calculate in all these cones what is called the sector angle theta, which is given by the formula R by R into 360. What is the small r? Small r is the radius of the base. Diameter is 50, so radius of the base is going to be 25. And what does this capital R represent? This capital R is the true length of the generator or length of the end generator. Here O dash E dash is one end generator. Similar to that we have O dash A dash, another end generator. And this R can be found out only after construction of this triangle in the front view. So this is called R, the true length of the generator. So that I have shown here, friends. So this R can be obtained only after the construction. 360 degrees is a constant, so we will be able to find out what is theta. Theta can be calculated. Now, after calculating this sector angle theta, I am going to write a line, this vertical line, say, of length r. So, after this, I am going to draw another line at an angle of theta, whatever the angle you get here, I am going to mark here. And after marking this sector angle, we will have to divide this sector into some number of parts. As you can see, the top view of the cone is divided into 8 equal parts. So also it has to be divided into 8 equal parts. So like 1, 2, 3, 4, 5, 6, 7 and 8. And friends, now we'll have to draw the development of the part between S1, S1 and S2, S2. So this is the part which I am going to call it as part P. Say. This part is to be developed now. Friends, how to draw that now? Now let us start with the section plane S1, S1. And before that, we'll have to see what is the starting point for this. Is it OA or OE? And if you observe the front view, none of the slant generators are totally removed by the section plane. And hence, you can start the development from point A, B, C, D, whatever it may be. Say I am starting from point A. This is A, B, C, D, E, F, G, H, and finally A again. The starting and the end point should have the same marking. Friends, next, if you see the section plane S1, S1, it is passing through A of the bottom page. So I can just mark the point A here. So this is one of the points for this section plane. One only I am marking. One point. Then it is cutting OB and OH. This is B and this is H. OB and OH are cut here. It is not a true length. So I am going to shift that to the last line, true length line, either to the right or to the left. Mark this distance on OB and OH. So this is OB and this point is OH. So we have marked 2 points. Then friends, you can see the section plane is cutting OC and OG here. It is again not the true length. Shift that to the last line, last generator. Mark that distance on OC and OG. So this is a OC and this is OG. Friends, next OD and OF. This is D and this is F. OD and OF are cut here, and this is not the true length. Shift that to the last line, mark that distance on OC and OG, OD and OE, OD and OF, So this is on OD and this on OF. So friends, we are left with a loss generator. O dash E dash is cut at this point, and this is the true length of the generator. Simply you can mark this distance from the apex till here. That is on the point OE. Friends, we have got all these points. So let us join the points so obtained by this section plane by a smooth continuous curve. So friends, I am going to join like this. It has to be joined by a continuous smooth curve without any break in between. This is how the section plane when cut, section plane is cutting the solid, we have like that. Friends, similarly, you follow the procedure to obtain the points on this sector where section plane 2 is cutting. So let me start from this point. So this point is on OA. OA is the true length of the generator. So mark that on OA. Suppose say this is point OA and again on point OA here. Yeah, this is point on OA, right? Then OB and OH are cut here. It is not the true length. You can shift that point to the last generator and mark that distance on OBOH. So OB and again on OH. OB on OH you have marked. Next, OC and OG are cut here. It's not the true length. Shift that point to the last generator and mark on OC and OG. Yes, I am going to mark it here on OC and also on OG. You have marked that. Next, OD and OF are cut here. These are not the true length line. Shift that to the last generator and mark that distance on OD and OF. So I am marking this OD and OF here. Finally, friends, we are having the point, this point on this generator, O dash E dash. This is the true length of the end generator. I just mark the point here. Now, friends, we have got the points marked on all the 8 generators. Again, I am going to join all these points by another smooth continuous curve. Like this, you should join. Friends, this is how you will get it. And you can see the generator O dash A dash. You have this much of portion left over. So that has to be joined by a dark line or a visible line. Similarly, this side, it has to be joined by this. And all other lines, whatever you have, should be shown by very thin lines, making use of pencils like HR2H pencils. Friends, if you call this part between the section planes S1, S1 and S2, S2 as P, this portion, I'll show you the curve. This portion will give you the development of P. There is a lateral surface of the part which is in between section plane S1, S1 and S2, S2. Dear friends, before I complete this video, I have an earnest request to make to you all, particularly the students and the faculty. Friends, I am spending a lot of time to make useful videos for the benefit of the teaching community and also the students. So I make a sincere request to all of you to subscribe to my channel without fail. Give a liking to my channel and to my videos if you like them. And again, I request all those channel viewers who are not subscribed to my channel so far, please make it. Your subscription is going to be a very good motivator for my efforts, and I have a target of making not less than 1000 useful videos on this particular subjects, machine design and engineering drawing. Friends, please go through the complete video and share it with your friends without fail. And once again, I thank you very much for the cooperation you have been giving all these days, and I expect from all of you to continue the same support. Thank you, friends. Have a blessed day.